Hi! The topic of this video lesson is points, lines and segments. We know we can draw straight lines with a ruler. Although we can only draw a part of the line, on the plane, the line is actually infinite. She goes both ways to infinity. We draw part of the line. A straight line is denoted by a small Latin letter, 4x, this line. No matter how straight the line is, we can mark the points that lie on this line and the points that do not lie on this line. For example, point A is positioned on line A. Likewise, point B is situated on line A. Notably, both points lie on the same line, namely line A. As an illustration, point C is not located on line A, and let's assume that point D is also not located on line A. The phrase point A on line A is usually abbreviated to the following characters. Writes point A and puts a sign of belonging. Sign of belonging resembles Russian letter E in reverse. Letter A belongs to the line A. In the same way, we can assert that point B is a member of line A in a similar fashion. Else, line A passes through points A and B and does not pass through points C and D. If we state that point C is not on line A, we can express it as follows. The sign indicating belonging is crossed out. Point C does not pertain to line A. Additionally, point D also does not pertain to line A. Now, in the case where we have point A, line A, points A and B marked on it, we can represent line A in a distinct manner. We have the ability to denote line A as line A, B by using 2 points. It is more convenient to designate not just with 2 letters, but to highlight with brackets. In parentheses, it means this is line AB. Often, to avoid confusion with a segment or array, parentheses are also utilized. Then, based on the information given, we can confidently conclude that point A is a part of line AB. If we mark an additional point E on line A, then we can refer to line A not only as line AB, but also as line AE in this particular case, because it passes through these 2 points as well. Or alternatively, we can call it line EB. In general, if we have 2 points, we can draw a single straight line through them, only one straight line. In other words, I have the option to designate the line AB as the line AE, or the line EV, or the line AB, as we initially named it. In general, through any 2 points, assuming that these points are not coincident, only one straight line can be drawn. In this case, it means that these lines AE, AB, BE, and line A are all identical to each other. Consider how 2 straight lines can be positioned relative to each other on a plane. If 2 straight lines have one common point, only one, then it is said that these lines intersect. Let's assume this is line A, this is line B. According to them, line A intersects with line B. This is an intersection sign. On certain occasions, if we mark this point, let's say O, we can indicate that line A intersects with line B at point O on the diagram. In an alternate scenario, if we mark any points on line A, let's say point A and point C, and locate point B here, we can confidently state that line AC intersects line BE at a specific point, which we shall denote as point O. It can be asserted that point O is a part of both line A and line B, indicating a shared membership between the 2 lines. For example, point C belongs to line A, but does not belong to line B, and so on. Now, if 2 straight lines do not have common points, then it looks something like this. Then they are called parallel. Parallel lines are lines that do not have any common points. They denote it in this manner, a parallel to B. Therefore, it can be observed that 2 straight lines can either have only one point of intersection or have no points of intersection whatsoever. If 2 straight lines had, say, 2 points of intersection, then through some 2 points, suppose here there is a certain straight line. I will depict it, of course, crookedly, but we imply that 2 straight lines intersect at 2 points. Then, according to the previous rule, only one line can be drawn through 2 points. These lines would coincide, and such a picture is impossible. That is, 2 straight lines on the plane can be arranged as follows. Either they intersect, like A intersects B, or they are parallel. Now let's move on to the segments. Let's say we have a certain line. Let's mark 2 points on this line. Let's assume point A and point B. It can be observed that point A and point B define a specific part of the line segment. So, a portion of a line that is bounded by 2 points is referred to as a segment. That is, from A to B is a segment. Usually, a segment is denoted by 2 capital Latin letters, which represent the ends of this segment. Points A and B are the ends of the segment. It is designated either simply as AB, but in this case we can confuse it with the direct AB, so it is often denoted in square brackets AB. This is segment AB. We can say, for instance, let's make a note of point C at this spot and point D at this spot. For example, point C. We see that point C lies on line A, or we can call this line AB. Point C is a member of line AB, but it is not a member of segment AB. To avoid confusion, as the notation is the same but implies a line here and a segment here, it is best to use brackets for clarity purposes. We denoted a line in round brackets, a segment in square brackets. Then it becomes clear that point C belongs to line AB, but point C does not lie on segment AB. Point D. Point D is part of line AB. Point D is also part of segment AB. As can be seen, it is part of both the AB segment and the entire line as a whole. This video is now complete and finalized, with all the necessary information conveyed in a clear and concise manner.